Kubernetes and GKE Part 24. This episode has 4 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Describe resources. Here's a strong way to approach it. Kubectl describe pod mypod 4. Delete resources kubectl delete pod mypod 5. Debugging kubectl logs mypod kubectl execute mypod. Or bin or bash key features manages entire Kubernetes cluster works with YAML manifests supports declarative and imperative commands provides real-time cluster interaction kubectl versus Kubernetes. Components component role kubectl client tool. User interface. Kuba API server central control plane API Kuba scheduler assigns pods to nodes kubelet runs containers on nodes simple analogy think of Kubernetes as a smart city. Cluster equals city kubectl equals remote control or command app used to manage everything in the city important concept kubectl does not directly manage containers. It always talks to the API server, which enforces all cluster changes advanced usage kubectl rollout, deploy or rollback apps, kubectl scale, adjust replicas, kubectl port forward, debug services, kubectl top, monitor usage. Interview-ready definition kubectl is the command line interface tool for Kubernetes that allows users to interact with the cluster by sending requests to the Kuba API server to create, manage, inspect, and debug cluster resources such as pods, deployments, and services. Nice. Let's continue. Question 2. Explain kubeconfig. Here's a strong way to approach it. A kubeconfig file is a configuration file used by kubectl to connect and authenticate to a cluster in Kubernetes core idea. Kubeconfig tells kubectl which cluster to connect to, how to authenticate, and which user or namespace to use. Without kubeconfig, kubectl doesn't know where the cluster is, how to access it, what permissions you have, why kubeconfig is needed. It enables secure authentication to clusters, switching between multiple clusters, managing multiple users and environments. Dev or staging or prod, defining default namespaces and contexts where kubeconfig is stored by default, or .kuba or config. You can also use a custom file, kubectl. Kubeconfig equals or path or to or config get pod structure of kubeconfig. A kubeconfig file has 3 main parts. 1. Clusters defines cluster details. API server URL CA certificate. 2. Users defines credentials, certificates tokens exec authentication, cloud login. 3. Contexts links, cluster plus user plus namespace example kubeconfig API version, v1 kind, config clusters, name, dev cluster. The exact commands and code are in the written question bank. Great, moving on. Question 3. Explain IceGeo. Here's a strong way to approach it. IceGeo is a service mesh platform used to manage, secure, and observe microservices communication inside clusters like Kubernetes without changing application code. Core idea. IceGeo is a traffic control system for microservices that sits between services and controls all communication. It implements a full service mesh using sidecar proxies. Why IceGeo is used in microservices environments. Services communicate heavily with each other. You need retries, security, routing, and monitoring everywhere. Adding this logic inside each app is complex. IceGeo solves this by moving networking logic out of applications, handling it at infrastructure level. IceGeo architecture. IceGeo has 2 main parts. 1. Data plane made of Envoy proxies runs as sidecar container in each pod, handles all inbound or outbound traffic. 2. Control plane called IceGeo manages configuration and policies, distributes rules to Envoy proxies. Traffic flow service. A. Envoy proxy service. B. Key features of IceGeo. 1. Traffic management, load balancing, request routing, traffic splitting, canary releases, A or B testing, fault injection, for testing failures. 2. Security, zero trust, mutual TLS, MTLS, between services, automatic certificate management, service identity-based authentication. 3. Observability metrics, latency, error rate, traffic volume, distributed tracing, request flow across services, logging and monitoring. Integration. How IceGeo works. Simplified. 1. You deploy IceGeo in the cluster. 2. Sidecar proxies, Envoy, are injected into pods. 3. All traffic goes through Envoy. 4. IceGeo configures traffic rules and security policies. 5. Envoy enforces them at runtime. Example use case: Canary deployment, 90% traffic v1, 10% traffic v2. IceGeo handles this without changing app code. IceGeo versus Kubernetes networking feature. Kubernetes IceGeo service. Routing basic, advanced security limited. MTLS. Identity-based traffic control, no fine control, full control. Observability basic, deep tracing plus metrics. Simple analogy: think of Kubernetes equals roads and basic traffic system. IceGeo equals smart traffic controller with surveillance, toll gates, and routing rules. Components of IceGeo: Envoy proxy handles traffic, data plane, IceGeo control plane, config, security, discovery, ingress or egress gateways, control external traffic. When to use IceGeo: large microservices systems need advanced traffic control, strong security requirements, zero trust. Observability at scale. Downsides: complex setup, resource overhead, sidecars per pod, steeper learning curve. Interview ready definition: IceGeo is an open source service mesh platform that manages microservices communication in Kubernetes by deploying Envoy sidecar proxies for traffic control, security, MTLS, and observability, all centrally managed through the IceGeo control plane without requiring changes to application code. Alright, next question. Question 4. What is Linkerd? Here's a strong way to approach it. Linkerd is a lightweight service mesh used to manage service-to-service communication, security, and observability in microservices environments running on platforms like Kubernetes. Core idea: Linkerd simplifies and secures communication between microservices without changing application code. It provides a minimal, fast, and easy-to-operate service mesh compared to heavier alternatives. Why Linkerd is used in microservices architectures. Services communicate frequently. You need reliability, retries, metrics, and security. Adding this logic in every app increases complexity. Linkerd solves this by injecting lightweight proxies into pods, handling all network communication automatically. How Linkerd works: Linkerd uses a data plane plus control plane architecture. 1. Data plane: lightweight proxy called Linkerd proxy, Rust-based, runs as a sidecar container in each pod, handles all inbound or outbound traffic. 2. Control plane manages configuration and policies, provides service discovery and telemetry, pushes rules to proxies. Traffic flow service. A Linkerd proxy service. B. Key features: 1. Traffic reliability, automatic retries, timeouts, load balancing, circuit breaking. 2. Security, mutual TLS, MTLS. By default, automatic encryption between services, service identity-based authentication. 3. Observability, real-time metrics, latency, success rate, traffic volume, service level dashboards, distributed tracing. Integration: Linkerd versus IceGeo. Important comparison. Feature: Linkerd IceGeo complexity low, high performance very lightweight, heavier setup simple, complex flexibility limited, advanced features highly customizable. Proxy: Rust-based proxy, Envoy proxy. Simple analogy: think of microservices like people in an office. Services equals employees. Linkerd equals simple receptionist system that connects calls, ensures secure communication, tracks who talks to whom. When to use Linkerd: you want a simple service mesh, you need fast setup and low overhead, you prefer minimal configuration, you are running production microservices with basic mesh needs. When not to use Linkerd: you need advanced traffic shaping, complex canary rules, you need deep extensibility and custom policies. Large enterprise mesh with heavy customization needs. Key benefits: easy installation and operation, lightweight and fast, strong security by default, MTLS, good observability out of the box. Interview ready definition: Linkerd is a lightweight open source service mesh for Kubernetes that manages service-to-service communication by deploying sidecar proxies to provide automatic MTLS, security, load balancing, retries, and observability with minimal operational complexity. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.